Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we will begin looking at digital representation of values, how we use digital signals, how we represent numbers and characters. Well, let's start with, as we talked about before, a digital signal is typically either a 1 or a 0 value. A 1 may be represented by, say, 5 volts. It could be represented by 3 volts. Whatever in our particular system we use to represent those digital signals, that's what the 1 would be and what a 0 would be. Now, think of these as a 1 is a light switch turned on. So if I've got a light switch and it's in the on position, that would be a 1. If I've got a light switch and I move it to the off position, that would be our 0. So all digital electronics is basically either a switch turned on or turned off. Now, if we have more than one switch, let's say we have 2 switches, and I'm going to call these switches 1 and 0. No, let's call the switches A and B. And if I've got 2 switches combined, well, the values they can have, either one of them, switch A could be either on or off, as well as switch B on or off. And they could work, if we work together, they can be in any combination. So we can build a table of the possible combinations with switch A and B and on or off of either one. Well, we could have both A and B on. That would be a 1-1. We could have A and B both off. That would be a 0-0. Those would be 2 combinations. Well, what if A is on and B is off? That would be, say, a combination of 1 and 0. And the 4th combination would be a 0 and a 1, where A was off and B was on. So with 2 of these switches, we can have 4 values or combinations. So 2 switches give us 4 combinations. Well, let's say we go with 3 switches. A, B, and C. Well, let's look at all the possible combinations there. Well, we could start with all 3 of them could be off. Well, the first 2 off and the 3rd one on. Off, on, off. Off, on. Well, what about then the A on, and the next 2 off? And we could go through all of the possible combinations and if we do, what we find is with 3 switches, we end up with 8 combinations, or 8 possible values. Well, if you were to expand that to 4 switches, we would get 16, 5 switches, 32. So what we have is 2 raised to the n power for the number of combinations. So if we had there that 3 switches to the 3rd gives us 8 combinations. Very typically in a digital electronics circuit, we use 8 switches to represent our value or our character. 8 switches, that's 2 to the 8th power, or 256 combinations. So using 8 switches, or 8 of these digital ons and offs, that gives us 256 combinations. Well, each one of those switches I'll just say SW here, we call that switch a 1 bit. 1 bit. Now if we combine 8 of those switches together, or 8 bits, we call that a byte. And byte is typically the unit of storage in a computer system that we talk about or work with the most. When we talk about storage and these banks of switches and groups of switches we have in a computer system, we talk about how many bytes, and just some terminology that we'll hear there. We'll hear of kilobytes. A kilobyte is actually 2 to the 10th, or 1024 bytes. We'll hear a megabyte. That's 2 to the 20th, which is a little over 1 million. And if you want to find out the exact number, you can get your calculator out. A lot of times today, when people talk about millions and later on billions and things, a megabyte, they actually round it to a million. And that's very typical, for example, in a hard disk drive, where if you buy a hard disk drive that, say, is a terabyte or a trillion bytes, when you look at it, they have rounded it to the trillion, not the 2 to what we'll see as the 40th power, which is somewhat more than that. And depending on how your computer displays storage, when you look, it says instead of a terabyte or a trillion bytes, it says maybe 900 gigabytes rather. And you say, well, did I get ripped off? Did I get a smaller hard drive than they told me? No, it's that the hard drive manufacturer is representing a terabyte as a billion, not 2 to that 40th. Well, the next one up is a gigabyte, and that is 2 to the 30th power, or somewhat over 1 billion. And a terabyte is 2 to the 40th power, or somewhat more than 1 trillion. Okay. So as we're representing these digital systems and these bits and bytes, we may deal with large quantities like this. Well, the other thing that we'll be doing, or we'll be working mostly with a small number of bytes. So we'll actually start and we'll work at things that are 1 bit in size. Then we'll move to bytes. But there's something in between. A half of a byte is 4 bits, and that is called a nibble. And no, I'm not making this up. If in fact, there used to be a magazine devoted to Macintosh computers called Nibble. So when we may talk about smaller units there in terms of bits and bytes and nibbles as we go through the course. Okay, let's go ahead and close this video out now. I'd like to thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future episodes. Also, please check out our other channels and subscribe to our other Dan on Tech channels and our Dan on Tech channel and our playlists. And thank you.